Welcome to SS2 Physics, Term 1, Week 3. Today we study thermal expansion, the tendency of matter to change its size and volume in response to temperature changes. When heated, atoms vibrate more energetically, pushing each other further apart and causing the material to expand. When cooled, the reverse happens. Thermal expansion affects bridges, railway tracks, electrical power lines, thermometers, and even dental fillings. Engineers must account for expansion in every large structure. By the end of this lesson you will understand linear, area, and volume expansion, know the relevant formulas and coefficients, and be able to solve numerical problems. Let us begin. In solids, we distinguish between three types of expansion. Linear expansion refers to the change in length of a solid. The formula is delta L equals L naught times alpha times delta T. Here delta L is the change in length, L naught is the original length, alpha is the coefficient of linear expansion, measured in per Kelvin or per degree Celsius, and delta T is the temperature change. The coefficient of linear expansion varies by material. For steel it is approximately 1.2 times 10 to the power negative 5 per Kelvin. For aluminium it is 2.4 times 10 to the power negative 5 per Kelvin. For glass it is about 9 times 10 to the power negative 6 per Kelvin. Example, a steel railway line is 20 m long at 20 degrees Celsius. How much does it expand when heated to 70 degrees Celsius? Delta L equals 20 times 1.2 times 10 to the power negative 5 times 50. Delta L equals 0.012 m or 1.2 centimeters. This is why railway lines have expansion gaps between sections. Without them, the tracks would buckle in hot weather. Area expansion is the expansion in two dimensions. The coefficient of area expansion beta is approximately twice the coefficient of linear expansion, beta equals to alpha. Formula, delta A equals A naught times beta times delta T. Volume expansion, also called cubical expansion, applies to solids, liquids, and gases. The coefficient of volume expansion gamma equals 3 times alpha for solids. Formula, delta V equals V naught times gamma times delta T. Or the final volume, V equals V naught times 1 plus gamma times delta T. For liquids, we use the coefficient of apparent expansion when measuring in a container, because the container itself also expands. The real expansion equals the apparent expansion plus the expansion of the container. An important exception is water. Most substances contract when cooled and expand when heated. But water between 0 and 4 degrees Celsius actually expands as it cools from 4 to 0 degrees Celsius. Water reaches its maximum density at 4 degrees Celsius. This anomalous behavior of water is crucial for aquatic life. Lakes freeze from the top down, not from the bottom. The denser water at 4 degrees Celsius sinks, while ice floats at 0 degrees Celsius, insulating the water below and preserving fish and other organisms during winter. For gases, the coefficient of volume expansion at constant pressure is 1 divided by 273 per Kelvin, derived from Charles's law. Thermal expansion has countless engineering applications. Expansion joints in bridges allow the structure to expand and contract safely with temperature changes. You can see these joints on the Third Mainland Bridge in Lagos. Bimetallic strips, made of two metals with different coefficients of expansion, bend when heated and are used in thermostats and fire alarms. Thermometers work because mercury or alcohol expands up a narrow tube. Overhead power lines are installed with a sag to account for expansion in hot weather and contraction in cool weather. Tight fit joints in engineering, called shrink fits, use differential thermal expansion. A metal sleeve is heated so it expands, placed over a shaft, then cooled to grip tightly. Summary, linear expansion, delta L equals L naught alpha delta T. Area expansion, delta A equals A naught beta delta T, where beta equals 2 alpha. Volume expansion, delta V equals V naught gamma delta T, where gamma equals 3 alpha. Water has anomalous expansion between 0 and 4 degrees Celsius. Thermal expansion is exploited in thermostats, thermometers, bimetallic strips, and expansion joints.